Hello and welcome, and this video we will do quite a lot of stuff, so make sure to subscribe, like, and let's go into this. So the first thing we're going to do is fix our random direction spread. So we're just going to do the simple thing, as you can see, angle X and angle Y, and I'm going to remove the system so that we don't need to use the Unity engine. We don't need to be specific about it, and we can actually have two angles because I noticed that it's very it's like the other one is affecting the other angle, which is not good anyway. So that's done. Now we should have it fixed. Let's have dry. And if I take a fast weapon, like maybe this one here, yeah, we'll fix this problem as well, where when we are clipped, then we have issues interacting. So you can see the shooting forward random is now more random. As you can see, it looks more realistic. Previously, it was like it would always go in one line. I mean, randomizing the up direction or randomizing the right direction, same was not looking good. So now, let's do the next thing. Prevent leaning if in interaction range. Quite simple. Let's go over here and define a boolean is in interaction range and set to false by default. Next, we'll just come over here and define a new function. So this function's name is handle interact UI state, bool state. If state equals to true, else you get a simple else statement as well, and we'll set its use false if false and set it true. So enable the interact UI. Otherwise, we just get a component and set the text as well. We also need to get an interactable and set to null by default. Next, we also have a no interact UI state. This is going to basically interactable is not equal to null. Then we want to set the message of it. Now we can use our function in all cases, as you can see. Place everything with it and pass and full and practical. And we can also then remove this because this is useless as the function held with ourselves. Next, inside the function, we will set its interaction range to true. Similarly, false. Next, we can continue. So in the try roll function, instead of using this not breakers, we'll check if its interaction range is false. So that will be more nice and neat. Next, in the leading input area, we're just gonna check if it's true. Then you set it to 1. I mean, not 1, the actual input, and otherwise 0. Let's try it out. Save the project, and if we come over here to the other weapon, and as you can see, something is not okay. I think we need to fix this. So you can't lean by default even. I think I have made a small mistake. So if you come over here, everything seems okay. We are setting it to true if true and false. In the leaning area, we have to check if it's false, not true, because that's literally the opposite thing I was supposed to do. Now, let's come over here, and you can see we can lean if my interaction was like aiming at one point. So you can see it is much better than what we had previously. And we can also interact with objects. So now we do the other thing, which is separating UI completely from player. I know this is not going to be completely separated though. We'll separate it later on in this video when we have the P2 of this video. Basically, in a part of this video, the last part of this video maybe. So firstly, we're just gonna find this Crosshair UI game object, and I'm gonna actually define it inside player UI. And from here, I'm gonna make it Crosshair UI. Define a function, set Crosshair. This function, set Crosshair show, is gonna take a bool show, and we'll just set this to the show. Alright, now over here where we're actually setting it, you can have a reference to the player UI because that's our player UI script. How it's going to work is at the bottom. Just all the code seems to go to that. Let's go to the player UI area and define a player UI so we can reference it. It's for the UI section and supervision will live. Now at the bottom we're gonna say set crosshair show, and we're gonna pass in not is aiming so that if it's aiming is true, it's gonna pass in false and false and true. Now we can try it out. Actually, we have an error. We not drag the reference. Now we try it out. Still have an error, which we don't pass in player UI. But as you can see, the crosshair is actually changing. It disables and enables at the correct times, which is actually good. Now we can pass in the reference just so that we don't get an error next time playing. Now we still have one more thing to finish. The actual interact UI is actually manually set, and that's not very good to us. Instead, we can define a public void inside the player UI again, set interact UI show, another game object, interact UI. This game object is gonna set, basically this function is gonna set it just like the other one. And we'll also check if it shows equal true, then if shows equal true, then we also want, an I interactable equals null. And then we also want to check if that's not equal to null. Then only we will just get a component in children and just paste the same code, and it should work. Now we'll just comment all this out and use our function that we defined. So player UI dot set interact UI show through, and we'll pass an interactable. Similarly, we'll pass it. Right, next we'll just remove that object as we don't need to keep it anymore, and that's cool, right? Next we'll just come down over here, and I'm going to assign my reference, hit the play button, and let's try it out. If yep, the interact UI is enabling and disabling at the right times, which is really good and exactly what we're looking for. So I'm going to come out of play mode now, and let's save, delete all these commented codes as they are no longer needed. So next we'll just remove TM Pro, as we don't need that either. That's all UI stuff. Cool. Now the next thing, improve look limit system. So that's basically going to improve our look limit system. We're going to allow the user to choose between both the height, the up angle, and the below angle, and that's cool. And another problem is this thing over here, as you can see. When we lean, because of our technique that we're using, we actually apply it to the Y as well. So it causes this jerk. So if we can just set it like 1 degree, let's say, and that will fix it. But anyway, we have to create a new script in the player, an up down look limit. This is gonna actually limits actually not limit. It's gonna use system as serializable. Next, it's a public. It has a public float. Max look up, set it to 989 actually. We're gonna range it between 0 and 89. We also need a max look down, which is going to be lookup limit. Actually, I can rename that to look down limit. So the look down limit is going to be set to 89 by default as well. Next, I'm going to create a C# script again, up down other max look limits. I think max look amounts will do. This is another one, it's serializable. Again, system we need. So let me just get that. Next, we pass in serializable. And this one's going to actually hold up down look limits, and it's going to hold up down look limits look amount normal. It's going to hold a look amount for the moving, a look amount for the unground where he's in the air. Okay, now we just define that max thingy, which is very simple. We are just going to define 3 more floats, max look up and max look down, or look up limit and look down limit. And we're just going to pass a new serialized field, and it's going to be a max amounts. Secondly, we can have a small space that looks into. Alright, now we're just going to come over here and define small spaces between these nice little variables that we define over here inside this function. Sorry, this class. Next, we can also remove it from above because we already have a space on top. So next, we can see that it looks really good. And that looks really, really nice. It's got sections. Unity just creates those property drawers for that. Anyway, we just add a small space again to 3. Decrease the space, And I'm going to comment that code out because I want to create a function which will handle our max look amounts for us. Alright, we're going to take in some stuff. The first one is a bool, is moving. Next one is a bool again, is unground. And then a ref, which is a float of max look up. A ref, which is also float, but max look down. And a ref, or rather float, which is the look max change speed. We'll define another private void function. This function is going to be used for setting look limits. This one will take as ref, float, and this one will take in the max look up and the max look down. And also we'll take the target look limit up and also a target limit look down. Target limit down. Max look up and max look down. So that's good. Then we'll set the max look up in this function to the method from max look up to the target limit up. We also need the float with max change speed, which is gonna be used to smoothly set the target. Next, we use the max look down in the same place. We just switch everything to down, 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 down. So it's done for both. Now we'll check if we are in the air. if that's so, else if we are moving, and else. So we've got three statements. Now we can just simply say, okay, set look limits in the first one. Ref passing in max look up, ref passing in max look down, and also passing in the target limit up. I mean the target limit up, right? Target one, which is going to be max look amount dot look amount unground. I'm gonna put that on top because it's the most important one. The look normal and then ground and then moving. And I'm gonna pass in the unground limit down and limit down, look limit up and limit down. So, and pass in the look max change speed. Copy the same function, paste it here, and instead of unground, we're gonna use moving instead. Similarly, for that, we're gonna keep it moving. And if you paste again, this time's normal and normal, which has just been quite similar to next. We just have to call this function now, pass in the required parameters. Cool. We'll pass in the lookup limit, the look down limit, and actually we need to pass in the boots first, which is going to be the if the input player is not equal to 0, which is going to be true when we are actually getting some movement. But and anyway, the rest is quite simple. Next, we just get a summary for this function and a summary for the other function as well. Cool. Save, and let's get out here. So now we have these nice limits just set for us already by default at some amounts, which we will have to change, of course. Anyway, I'm going to actually set the explanation to the lookup limit instead of the other one. And so we're going to be using the two new limits, which are signed by us. Now, this is going to be 75, I think, and 80. It's being good, 85, and this one to 82. Yeah, just find these is kind of simple. Like you've got sliders as well because I arranged them up. The command moving can be something like that. Hitting play, you'll see that if I look all the way up, I am limited to the limit, and I can change the limit in real time as well. So which is pretty good. I'll save that out and come back here. Now let's go to the weapon base class and define a current lookup limit because we need to do this underneath soy rotation quaternion. And we can say controller.get lookup limit, please. So controller is going to give us that in a bit, and get look down limit as well. So for these simple statements, it's going to be get rotation dot if that is greater than current look down limit -1, and also another simple statement. Now we can define two functions to return the lookup limits and lookup down limits. Save that out. Now we can go back to the weapon base. These two functions are going to just return us the values. And nothing's wrong now. Let's go and try it out. So actually you can see the sway is kind of locked and it doesn't work at all. And I actually found out that this minus is not needed over here. Everything still works now. So now if you see the sway does work, and you'll see it more noticeable over here. And if I go all the way to the limits, you'll see this stop swaying, which is good, which is exactly what we want. Also, when I jump, you can see that the like actually goes through the hand sometimes. So we can change the limits. On the unground, we can change it to like maybe 50. Finding the best values will take you a bit of time, but yeah, the system does work. We have improved our max look limit system. We're just gonna make this more lesser, like 20, 28, or 25, 30. Now, as you can see, if I jump, yep, cool. Next thing, adding weapon heating system, the longest part though. So firstly, we're gonna get this asset Orca software has given for free. It gives a distortion shader in the asset store. You can search for Inflame and you get it for free. Thanks very much to the asset maker for Orca software. This folder I renamed it. So anyway, we're gonna use the distortion shader from there. Let's create a new C# script in here. We're gonna use Unity Editor. In the heat effects measures class, we need a heating one, right? So anyway, we add a region for the variables, a space, a header, general, a weapon base for the weapon, a tooltip for this variable, which is the weapon script of the weapon, Another float, which is a max heat value limit. It's ranged between 0 to 1, and a mean heat value limit, which is set to 0 by default and also ranged. Heat distortion effect. We need a simple space header heat distortion tooltip. Choose whether you want to use heat distortion effect. A simple boolean, which is going to check use heat distortion. Make sure that everything is actually hand inspector. That's because we're going to use custom inspectors. A tooltip for the heat distortion material. This material will be instantiated. Simple material reference, heat distortion material, and a renderer for the heat distortion renderer. The name of the heat distortion parameter, which is a string, heat distortion amount parameter name. Heating amount map is calculated based on the weapon's heating settings. Current extra heat and the and min max limits. It is mapped to 0. Alright, we have a space, object heating, header, and tooltip. Choose whether you want to use object heating effect. And a boolean again for the use object heating. We'll also make a new gradient, which is the heating gradient tooltip. First, we need to add that. Then we just define a simple hide inspector again, public gradient, heating gradient. Then a tooltip for the glow intensity multiplier. We can define a float, which is intensity multi. This is just 0 by default, and tooltip, which is the material that is assigned to your weapon's tip default. Default. Yeah, so I made a mistake here, so we'll fix that just in a while. Anyway, define two more materials: weapon tip material, weapon tip renderer. The emission color parameter name of the weapon tip material. That's going to be a string. So that's the variables, I think. Next, we'll define region for general. We'll create a new function named initialize and just call it instart. Instantiate an instance of the original material for the tip. Weapon tip renderer.material is equal to new material. Pass in weapon tip material. Alright, we're going to instantiate an instance of the original material for the distortion renderer as well. And then we're going to say initialize function. We can say all initialization goes in here. And in the update function, we can say handle effects. And we define a function inside the function region which we just defined. Handle effects, common has common section. We can say heating amount mapped is equal to method.up from the heating amount map to a method.up, which is mean heat value limit to max heat value limit. And we get current extra heat, which we'll just define a function in a while. Weapon dot weapon data, which is divided by that, so we can get a nice mapped value. Extra overheat threshold, which we'll define in a while as well. Float heating amount map left speed is equal to 10, and we just use that speed. Anyway, that's the common section. Next is the heat distortion section. We will just define, check if the user wants to use heat distortion effect, use heat distortion equal to true. If that's so, then we'll set the material dot float. The float is the heat distortion amount parameter name, heating amount map, and we'll close that object heating section now. Check if the user wants to use object heat effect. If that's so, we get the color, which is the color heating color equal to heating gradient dot evaluate. We pass in the heating amount mapped, which will be something like 1 and 0, and gradient will anyway return that's the correct thing. Anyway, next we set the color. Weapon did render dot material dot set color. We can pass in emission color parameter name. Heating color times the heating amount map times intensity multiplier. Okay, then we'll define a new region for the custom editor. The custom editor is going to be a type of the heat effect manager, a class heat effects manager editor from editor, and a region for the properties. We define a general section, which is going to be just serialized property for the weapon, serialized property for the max heat value, one for the min heat distortion effect. Over here, we can define the use heat distortion. Basically, we're going to have this boolean. Then also, we need to have the other three as well. So I'm going pretty fast because this is really boring. But anyway, we can just talk about it. So the heating gradient, and now the intensity multiplier. And the next one is the weapon material, weapon tip, and emission color parameter. Now we can define a region for the main. On enable function will do for us. We say general, find property. Now this function I'm going to define. I have functions region, which has a find property function, or CLF property, string name. sets the property called serialize.find property, pass in property, and the name only. You don't need the property. Anyway, we're gonna have another function which is gonna just draw property field, taking in the property. Draw property field, which is just literally property field. Anyway, that's helpful. Now we just define 3 of these and pass in the correct serialized values and the name. Similarly, we're going to define for the distortion effect as well. And finally, the object heating effect, which is just 6 variables, I think. And we're just going to paste all those names correctly with the name string correctly as well. Make sure not to make a mistake. After the onEnable function, we define an override void on inspector GUI. We call the base so that we get the default. Update it so that we can update the serialized object. Draw property field for the weapon. Then check if use heat distortion of bool value is equal to true or use object.bool value is equal to true. Then we'll add a small space of 3. We'll add an indent level 2 plus 1 and we'll draw a property field for the min and max, and then of course decrease the indent level back. We'll also have a section for the heat distortion effect. Draw the use heat distortion effect boolean. Check if it's true. If it's true, then we'll just again do the indentation so it looks nice and neat, and we'll define all of its fields in here. Alright, next we'll just come back and apply the modified. Now we've got this done, save it out. Now after the reload audio clip on the audio section, we'll define a new section, heating system. It will have a boolean which will say enable heating system equal to true. A simple tooltip will do. Yep. Next we'll just bring it down over here and define a public weapon heat state. So that's the heat state, and it's gonna be a private set and a public get weapon heat state.cool. It's the default value. We can define 2 more variables, one float and one bool, current extra heat, and bool for is cooling from overheat, which is a default by default. We'll handle weapon heating as a function we're going to define. And that's going to be done in update, not in handles when recoil. Next, we'll define that function. And we'll check if the enable heating system is equal to false. Then we want to set current heat equal to 0 and weapon heat state equal to cool, and is cooling from overheat to false, and return. Next, instead, if it continued, that means that we enabled it. So we'll set the current extra heat to current heat. If it's greater than 0, then we'll set it to minus equals weapon data dot constant heat cooldown rate per second times time delta time, and that's going to be how we'll do it. Otherwise, you check if the current extra heat is greater or equal to weapon data dot extra overheat threshold. That means that the state has to be overheated, and is cooling from overheat also true, because that would mean that we can't shoot, which means we'll be cooling down, as shooting won't be allowed. Cool. Next, we'll add an else if function, which is going to be basically checking if current extra heat is greater than equal to the extra heat cooling threshold. If that is true, then if we are actually cooling from overheat, then we'll set the state to cooling. Otherwise, it's cool. Next, we'll also check weapon heat state is equal to cool. Otherwise, if there's nothing like that, and set that to false. In the shoot function, we'll just add the heat every shot we do. It's simple. And now we're gonna come and add a region for the wall returns. Define a public float, get current extra heat, return the current extra heat, save that, and come over here. That's the save, and we get an error. Anyway, we're gonna create a new C# script for the weapon heat state. This is gonna be a public enum with the weapon heat state, cool, cooling, and overheated. Hit save and get out of this. Next, if we come to the weapon SO, we'll define a public float for the extra heat increase per shot. We'll define a float for the constant heat cooldown rate per second equal to 2F. Another float for the extra heat cooling threshold 25. Extra overheat threshold equal to 40. Awesome. Then the serialized properties so that we can actually draw them in the inspector. Yep, let's paste all those values. Let's go over here and find them first. Well, find the properties like that, and you pass in all these. Make sure to get them correct. Then we come over here and underneath Jack challenge should draw all these 4 properties. the extra heat increase per shot, constant cooling rate, and the constant heat, extra heat per shot, and everything else. Then in play functions, we're gonna come over here to the handle shooting and check or current weapon dot weapon heat state is not equal to cool, which means potential will be false if it's not equal to cool. And then over here, I'm just gonna change this to vector 0 to 0 inside the set spine constraint rotation. We get some errors because I had a typo. Fix that. Save and get back out. Enable depth and opaque texture because that's what you need for the distortion shader to work. And actually, I forgot to add the object heating section. So come back to heat effect manager and just draw the property field, use object heating. Check if use object heating dot blue value is equal to true. Some indentation will help, and a draw property for the heat gradient, density multiplier, and then two space again, and pass the material and the renderer. Emission color parameter as well. Then I've got to test the script as well because I did not want to lose my gradient and everything else. Anyway, create a new quad inside your weapon, the renderer, the quad renderer, and we pass in the actual distortion shader that has come in the package. And this is actually going to distort things. So we'll just reference the renderer and the material. So that's for the distortion. For the use object heating, we'll pass in the tip sand material and suppressor. And oops, we can see a problem here as well. Basically, I did not give the correct value. I should put in heat distortion parameter instead, not an emission because that's for the other one. So I'm going to pass in distortion amount as that's the one over here. If you see in the graph settings, underscore distortion underscore amount. Similarly for the other one, which is the, this is based on lit, and that's why it has got underscore emission color to control the emission color. If you see this lit shader inside your RP package, you'll see that it's actually called emission underscore emission color. So you must keep that right because we're using strings. And for the parameter, you can actually add these keys. You can see you should know how to use the gradient, otherwise you can go and find that out. But anyway, I'm just going to use my pre-made one because that's perfect for this job. I'm going to also paste the component values to the heat distortion renderer, which I already had previously when I was testing. Now if I hit play, we can see an auto shadow, which is not at all nice. That's because we have not turned off shadows. So just turn off all the shadows and all the dynamic occlusion, whatever stuff. We really don't know it, or rather keep it on. Nobody cares about that. And as you can see, my weapon is becoming yellow, emitting a yellow style or light. And that looks pretty nice. We can reload, and then if we continue shooting again, you can see that we actually make our tip completely red, and you can see we can also see some distortion going on, which looks nice. There's also some heating cooling time which takes, as that's the values that are defaultly set. Now I will just remove the testing script that I kept, and I'll apply the changes. Now if you see this weapon over here, it doesn't actually have a different mesh for the tip, so we'll have to update our script to actually work nice and neat for this job. We'll create a weapon tip heat data. We're gonna make this a view system and make it serializable. Remove the money behavior inheritance and all other stuff. Define a renderer for the tip renderer, a tip material, and the emission color parameter name. Complete. Just define one of the lists. So we're gonna define a list of weapon tip heat data, and we're gonna get an error over here, so comment that out. Instead, we'll do a for each loop. Weapon tip heat data in weapon tip heat data. Then we'll do weapon tip heater dot tip dot material and set them to the new material. Anyway, we'll come over here and do a for each loop inside the object heating instead of a simple direct setup. Set the tip renderer dot material to set color from the weapon tip heater dot emission color name, and we'll pass in heating color times heating amount map times intensity multiplier. And I'm gonna wrap this up in a custom editor. The custom editor wrap it up in the editor so that we can get errors in building. Now in the heat effect manager, I'm gonna comment out all the three and define a simple weapon tip heated as. I'm also gonna define a private bool. It's like an array of bools. Weapon tip heat data's elements foldouts, and another bool for the weapon tip heat data display list. We're gonna find the property for the weapon tip heat data's. We're gonna set the weapon tip heat data elements foldouts to a new bool. Weapon tip heat data's dot resize. Next, we're just gonna come down over here, comment this out. Instead, we're gonna say draw weapon tip heating data list, heat data list, passing in weapon tip heat data list, tip heat data, and the weapon tip heat data as the name, a ref for the data's element folder, and that's the weapon tip heat data display list. I'll take in stylize define a function for this now. Stylize property for that property. A string field name, a ref bool array, which is elements folder's array, ref bool display list. And we're gonna start begin horizontal. So this is a big function. Don't worry though. So begin horizontal, we display the name of the list and the arrow to open and close. So first we're gonna do a simple fold out of the array code and pass in the field name and display list and set it true. Add a flexible space. We can say GUI loud dot flexible space. Very simple. Display the size field. Size field can be displayed by drawing property field, property defined, property relative, array dot size, and the horizontal drawing. Edit a GUI loud dot and horizontal. Text style, we can do it define a GUI style for the text style. Set the normal to text color to white and font size 20 and font style to bold. Check if a list is expanded. If so, we're just gonna come over here and add an indent. So add plus plus indent. Ensure foldout's array size matches the array size. If elements.length is not equal to property.array size, we're gonna set it to a new bool again and pass in property.array size. Draw the background box. Editor GUI layout dot begin vertical, which is gonna be editor styles dot help box. That's gonna help us a lot, as you'll see in a while. We're gonna do a for loop for each of the array element. Add a small space between each element if we are greater than 0, of course. Begin horizontal drawing for the element and the button. Get the 3 serialized properties which are inside the actual list. We can say serialized property element and equals it to property.get array element at index. We'll also get the tip rendered property, define property relative. Similarly, the other 3 as well. Tip material and the tip emission color stuff. So we just change that to 4 instead of 3. Draw the fold out as well. Elements folder array I is equal to editor.fold out, and we're gonna pass in this special S. It's not working, I think. Wait, yeah, to pass in the bracket instead. Then we're gonna add a flexible layout, flexible space before reaching the bottom or before the button rather. GUI layout.flexible space. Remove button for each element. Basically, this is going to be a button which is going to be besides the element, so you can delete it. Anyway, a minus will do, a dash, and then a text style we can pass in for the style. Property to delete error at element at index and pass an I and break it so that we go back. Space of 20 and the horizontal layer. Now check if the folder is expanded. If so, simply if elements is I, then we'll say that indent level plus plus and draw all these properties. Material property, the tip render property, the emission color parameter property as well, parameter name, and then just remove the indent level. At the bottom, I'm also going to remove the indent so we can continue from the original. Add a space, GUI loud space to begin horizontal drawing. Check if the list has no elements, property.array is equal to 0. Then we want to actually tell the person that yes, you have no elements in this list, so we're gonna just do a simple label. Add a GUI loud.label field that is empty. And after that, flexible space again, GUI loud dot flexible space. Add button for adding an element. GUI loud dot button. You'll say plus text style. Insert a new element. So this is quite simple. We can say property dot insert array element and index property dot array size. Space. We'll say add a GUI loud dot space 20 and horizontal. GUI loud dot end horizontal. We will end the background box, which is very simple. GUI loud dot end vertical. And then out of this thingy, we're just going to say dot simple space at the end. Now if we save and come over here, as you can see, I can see a size field, which is not good. I only want to see the number, not the size. I don't want to see the label of the size. It's because our function takes in serialized field, and that's a serializable property, which is not good. Basically, what we need to do is use the editor GUI layout because you see, it will not work nice otherwise. So we're just gonna, well, we can't pass in anything, so we just comment that out and say editor GUI layout dot property field. And instead of using a function, we'll use find property relative array dot size. Instead, say GUI like style or not. So GUI content dot none, so there's no content. Delete the other one. So we save, we come back out. And as you can see, the field nice and neat looks, and we can actually change the number as well. Anyway, inside the weapon TP data, I'm going to set it to underscore emission color by default. It won't actually update because, even if I reset it, it's not going to update until I actually do another, I mean, it is going to work later on. We'll see. Even now, it won't work until I don't, I think you have to, I don't know, but I think it will work. I know it will work because I tested previously. Anyway, remove all the command codes and the tooltips which I use. Actually, we'll add the tooltips to the guys over here because they're saying right, so just put tooltips for them. And this is going to be a tooltip for this actual tip he did us. Alright, then remove that comment code, extension instant for all. Remove that comment code, save and get out of there. Now if I add, see that we got tooltips. Wow, great. I'm going to set it to underscore emission color. And I'm going to pass in the the first element. I need to pass in suppressor as a tip renderer. And then over here, if I find the suppressor, we get the sand materials. Pass in sand material. If I hit play again, you'll see that shooting, making me hot, just like it was previously, which is good. We can reload, so we can continue shooting. We can shoot again, and then you see why I'm doing this is because we need to be able to do multiple objects. Now, if I can add it to the AK-47, I can pass in the script of it. I'm going to save a project, and I'm going to pass in the heat distortion stuff first by going and getting that object, pasting it to the child, and resetting it, and then copying the fire point, pasting its position to it, just to line it correctly, like somewhere there maybe. Passing the heat distortion renderer and the material, and the name, which is going to be heat distortion. I'm going to then save it. Let's go over here and just set it by default as well, so that is good. Now we're gonna just paste the gradient, so it's nice, intensity multiplied 4, and weapon heat did us to 1, but we will need 2 at the end. So we're gonna create a cylinder. We're gonna make the scale super small, set the X to 90. I'm gonna paste it to the fire point position. Object heating effect 1. Move the capsule collider, set the cast shadows to on. I'm gonna make this really small, something like that. Just gonna find the perfect number. And I'm gonna pass in the black missing material, very basic. We just have a very much cylinder lit pipeline thingy with the black color and emission on. Then I'm gonna duplicate that cylinder and make it O2. This is for this part of the weapon. You can see why I needed it because the size of this is different. I have to scale it up more and scale on the Y as well. It looks like it's done now, and we've got simple illusion as the weapon actually had to, which the player wouldn't really notice a lot. I'm gonna use this properties because my thing has not yet been improved that it saved the element. It doesn't save the state of the element, right? When I click somewhere else, it forgets that it was open almost. I will actually fix that in a while. Anyway, now you can see that if I change the weapon to the AK-47, so let me just come overhead, get this weapon. Got it. Now I can shoot. Yep, and it becomes red out. We can see distortion going on as well, which is exactly what we're looking for. Yep. Now I'm gonna find the, oh, Here's the weapon, and if you have a look at it, the distortion seems to be quite small. I don't like it, so I would like to increase the size of this, maybe, and bring it backwards, maybe. I'm gonna, yeah, let me have a look at it again, heating up. So if I continuously shoot, I really can't see it because of my fingers, like, being behind. So I'm gonna set the scale to 0.5 now. So that's pretty big, right? So that we can see it way more nice. Save that out, apply that prefab, and we just come over here, just pick up this weapon. Got it. Now if I shoot, it becomes red out. And we can see the distortion going on really clear. And I actually fixed the interaction already in the previous video. Maybe quick improvement will do. In the scope effect manager, we currently do not add listeners for that. For the well, we are using these events, which is really not what I would like to do. And I have reference to the weapon already. Said I'm going to define two private void functions. Make this also private. On aim, well, actually, we already have those functions as well. So let's go over here, and we know that we need to do an on aim method or add listener on aim. Similarly, for the exit, add listener on aim exit. We'll also add a listener for the interaction on stop on check for scope enable. Do exactly what I. And we can remove all the events as they're no longer needed for us now because they're all done inside the script by default. Let's go back to Unity after saving our thing and try it out. So as you can see, the scope system is actually working just as it was working previously. But for this weapon, actually, we just want to see if this actually working. So if you see in the scope again, the camera is actually turned off for optimization, just like we wrote in the script. Anyway, now for this scope, for this guys, you might actually not be able to remove the aim camera enabled saving. I don't know why I did that, though. Let me find out. I think we can remove it. Let's find out. So you can see that. Yeah, we can remove it. Yep. Apply the changes, and let's go over here. Save it. And yep. So we're just gonna continue adding the weapon heat system as I had to do a quick fix first. Now let's continue. I forgot to add a remove button for removing an element, so let's add that. In the heat effect manager, below the add and the space, you're gonna pass in a dash and text style. Check if there are elements in the list. If that's so, you're just gonna check it out first. Property.array size if it's greater than 0. Then property.delete array element at index, and you're gonna pass in property.array size -1, and that's it. Pretty simple. Another thing is to save the state somehow. We can do this by doing edit a specific section inside the original script, putting these two like this over here, finding them as false by default for the enable. Anyway, we're gonna check if the length is equal to 0. If that's so, then only we want to create a new rule of it. Otherwise, it's okay. We also need to get a reference to the original, which means a target system, just like that, and then use it. I'm gonna make it public so that we can actually see it, and also hide inspector so that we don't see it in the inspector. We need to get a reference the same as in the uninspected GUI as well. Yep, done, complete. Everything works now. So now the state should be saved. As you can see here, I open this up and you can see I click somewhere else, come back, everything works. If I add more elements or decrease more elements. All right, cool. Next, now let's see this. Everything's working on this one as well. Nothing has changed. Now let's come to this place back and just remove and close everything up. Come to the weapon base script pack. And over here, we're gonna define, well, actually comment out the bool that says enable system. Instead, define it over here in the weapon SO, and it makes more sense. And we'll find it in the get light property references function. We'll draw it as well. And we'll check if it's actually enabled. If so, then only we'll draw the heating stuff. Now, in here, in the weapon, we'll use the weapon data dot enable weapon heating stuff. Save that. And as you will see, under scriptable objects, you'll find that it's can be enabled and disabled. If it's disabled, then the section is not drawn, which is good. Now let's go to weapon SO And at the top of this, we're gonna say tooltip enable to make the weapon heating system take effect, comma, you can add the heat effects manager component from heat effects. If you really want that, then only to a weapon. Next, we will check, rather not check anything, just going to go to the heat effects manager. Everything seems good. It doesn't look like anything went wrong, so let's save it out and go to shotgun. So if I find the shotgun, as you can see, the spectre is really horrible. I don't know why, but it's not drawing the custom button either. So I'm gonna just define a new shotgun editor, a custom editor. It's gonna be type of the shotgun, and I'm gonna use Unity editor only if we are in Unity editor. That's so that we prevent errors in build, and wrap this up in Unity editor as well. We're gonna derive from weapon-based editor, and that's gonna be enough to show us everything we need. So as you can see, we have the open weapon setup window and everything else, button, everything working. We're gonna make the player UI independent of player controller completely. Firstly, we're gonna just remove this comment in the weapon base, and I'm gonna go to the player UI script, define a public void set. Well, we're gonna set the current weapon UI. We'll take in a weapon base with current weapon as the name, and we'll do all this functionality, and then I'm just gonna comment that out now, and then I'm gonna make some spaces to make no need. Now this function needs to be called from the player controller, and we're gonna call it every update, because you see we can't call it in star. I mean, that would not be enough. So instead, I'm going to come over here in the update, and after everything's complete, player UI dot set weapon UI and pass current weapon. Next, I'm just gonna put in a comment update weapon UI, save. That's done, and then we can move back to Unity after saving everything. Now, if we hit play, most probably everything should work. You can see my ammo is indeed updating. Yes, we can reload, and the ammo does update correctly. Now, you see one thing, the UI seems wrong. I don't know, but the image is actually set, so that means that we've done something right. Yeah, so I've assigned the AK-47, never change that, so let me just create one for this one. I'm going to do that right now. So I'm going to duplicate the weapons to make one for AWM. Do Command D or delete. Only if you're on Windows, then delete. Otherwise, Command D delete all these squares except the one you want. And then it's going to set this to AWM icon name, apply it, and let's go back to AWM and drag the reference. And I'm going to change the icon, the actual icon crosshair for this weapon to basically be, I don't think we can use any of these because these are all like text to 2Ds, you know. We're going to use these later, maybe, for a more complicated crosshair system, but right now I'm going to keep them aside. But anyway, we're just going to pass in the basic one from here. We'll find one. I think we can go with this one, save that, double click, and we can now see that the UI is all updated, except that the icon looks very odd for this weapon. So I'm going to stretch it out. I'm going to really stretch it out to 50, 55, and 200 makes sense. Alright, so see you in the next video. Make sure to subscribe and like and share, so all that good stuff, and see you in the next video.